So I hope you've made it through the slides for Module 11. Most of that was vocab type stuff and some relationships between solute and solvent, trend type things. And then you were introduced to molality, which is pretty basic math compared to what we're going to do now. So I decided to, instead of putting this part in the presentation, I'm going to record 2 examples to make sure that you understand this because it's not as straightforward. I think it would be difficult to grasp just looking at a presentation for a lot of people. And if you need more help, of course, reach out or look through some of this in your book. But what I'm going to cover now is freezing point depression and boiling point elevation. And like I said, I'm just going to do an example of each. So essentially, if I add a solute to a liquid, I can change the freezing point or boiling point due to the composition of the solution. And I can calculate that change in freezing point or change in boiling point using a specific equation for each. So what this looks like for freezing point depression is delta T, which you'll remember delta is always changing, so change in temperature is equal to negative I times K sub F times M. And we'll talk through what each of these things mean. Okay, remember delta T, change in temperature, negative I is the number of ions in your solute. We'll talk about how to determine what that is. Kf is your freezing point depression constant. And M, you already covered for this module. M is molality. So you learned capital M molarity in module 10, lowercase m molality in module 11. Okay, so that's what each of my variables represent. So if I'm given an example where I say that I dissolved 15 grams of sodium chloride salt in 100 grams of water, a lot of times this is going to be something dissolved in water. And I'm asked to solve for delta T. How much am I lowering my freezing point by adding 15 grams of salt to 100 grams of water? You would be given that your freezing point depression constant is whatever based on the solvent. But so my K sub F for water is 1.86. This is going to be given in degrees Celsius per molality. And that will all make sense when everything cancels out. So from here, I have some information. I have a KF. I need to calculate my molality, and I need to determine my number of ions. So let's start with molality. So molality equals moles of solute over kilograms of solvent. So I need to calculate that M. Okay, so at current, I don't have moles of solute or kilograms of solvent. So I need to convert grams to moles for NaCl. I'm going to do that over on the side. So 15 grams, add sodium and chlorine together. We've done this many times for sodium chloride. We get 58.44 grams per mole, which gives me 0.257 moles. So that's how many moles I have that I would plug in here for moles of solute. Kilograms of solvent. My solvent is the water. So I need to convert 100 grams to kilograms. Divide by 1,000. So it's going to be 0.100 kilograms. Okay. So molality equals moles of solute, which we just calculated, 0.257 moles over kilograms of solvent, 0.100 kilograms, which is 2.57 molal. Lovely word. Okay, so that's my concentration, my molality concentration. Now, I have what I need for my delta T equation with one exception. I need to determine my I value. So I equals number of ions, we said. Determine what your solute is. In this case, I have sodium. NaCl breaks down into a sodium ion and a chloride ion. So that makes my I value 2. Because I have 2 ions present, one sodium ion and one chloride ion. If I had something like magnesium chloride where it's MgCl2, I would have 1 magnesium ion and 2 chloride ions. That would make my I value 3. Okay, and then anytime your solute is a covalent molecule, your I value will be 1 because it's not breaking down into separate ions. Okay, we can cover this again in class, so we're going to move on. So now I have everything to plug into my delta T equation. Delta T equals negative I, which is -2, times my Kf, 1.86 degrees Celsius per molal, and then times my molality, 2.57. Okay, those are going to cancel. I'm going to be left with degrees Celsius. That makes sense because I'm calculating a change in temperature. If you plug all of that into your calculator, you'll get negative 9.56 degrees Celsius, which means that I will lower the freezing point of this solution by 9.56 degrees Celsius. Okay. If the question asked you, what will the freezing point of this solution be? I'll write this out. What will the new, I'm running into my other question, new freezing point be? You would take your original freezing point, which would be 0 degrees Celsius for water. Use this delta T. You would get negative 9.56 degrees Celsius. Now, if you were working with a solution where your solvent had a different freezing point besides 0, obviously it wouldn't work out this cleanly. But with water, have nice easy numbers. Okay. You guys can't see this, and there's no one to tell me to move it. So what will your new freezing point be? Take your current freezing point, the known freezing point of your solvent, water 0, subtract the value you get here. I'm lowering the freezing point to get what your new freezing point would be. Okay? Now, we're going to do the same thing for boiling point elevation. The equation looks very similar. So for boiling point elevation, my equation is delta T equals I times K sub B, that's my boiling point elevation constant, times my molality. Okay, so the only one I'm going to identify here is KB, since we know what all the other ones are already. Boiling point elevation constant. Okay, so we'll do an example. If I'm given that I'm going to dissolve 20 grams, same thing, sodium chloride, in 1.45 kilograms of water, and I want to know how much I'm going to raise my boiling point. I'm going to be given that KB value for water, 0.512, same units as before. So I know that I need to calculate my molality of my solution. My water is already in kilograms. I still need to convert from grams to moles for my solute. So over to the side. 20 grams. Remembering that 1 mole, we calculated this earlier, is 58.44 grams. Grams cancel. I end up with 0.342 moles of NaCl. So now I can calculate my molality. So molality equals, I'll write it again, moles of solute over, that's okay, kilograms of solvent. So moles of solute over here, 0.342 moles over kilograms of solvent, 1.45 kilograms. Punch that into your calculator, 0.236 molal. Now I have what I need to calculate my delta T. So delta T equals, in this case, I, number of ions, same thing here. I have sodium and chlorine. So 2 times my KB, 0.512 degrees Celsius per mole, times the molality, 0.236. Variables will cancel. We'll be left with degrees Celsius. That's good. 0.242 degrees Celsius. That's how much I will raise the boiling point of 1.45 kilograms of water if I add 20 grams of salt. Okay, so if the question asked, what will be the boiling point of this solution? What's your normal boiling point? 100 degrees Celsius. Plus, what's your boiling point elevation? How much is it changing? And that would give you your answer, your new boiling point. This one's not such a drastic change. And I did it again. I didn't move the camera. So that's your new boiling point. Add what you get for your delta T to your current known boiling point, depending on your solvent, to get that answer. Let me know if you have any questions.